Okay, you guys, so you're going to be watching a section 14.3 notes video, and then you're going to be finishing up the kinetics packet. So the video will walk through the type of problems that you're going to be doing. So our question of the day today is similar to questions you saw in the packet and then we ended class with yesterday. So there are two parts. It says to write a comparison of the disappearance of H2 and O2 with the appearance of H2O. So this is going to be kind of that rate equalities. So remember, it's 1 over the coefficient and then times the rate. So for the hydrogen gas, the H2, it's going to be 1/2 the change in concentration of H2 over the change in time. And because it's a reactant, it's going to be negative. And that is equal to 1, which we don't need to write, of the O2. So negative, again, because it's a reactant, change in concentration of the O2 over change in time. And then we've got our products. So it's going to be positive 1/2 change in concentration of H2O over the change in time. Okay. So then we're going to use that to find, if we're given one piece of it, another piece. So it says, if the rate of disappearance of O2 is 5 times 10 to the negative 4th molar per second, what is the rate of appearance of H2O? So we're comparing the disappearance of O2, which is this piece, with the appearance of H2O. Okay, and we want to know what is the rate of appearance of H2O. So this here is the piece that we want to get by itself. So right now it's multiplied by 1/2. So if we multiply it by 2, we'll get it by itself. So -2, and remember this is the rate of O2. So -2 times 5.0 times 10 to the negative 4th equals, and then this is the rate of H2O equals the rate of H2O, which is what we're looking for. Okay, so it will be negative 1.0 times 10 to the negative 3rd molar per second. Okay, so since it's a 1 to 2, right, the H2O is twice as fast as the O2 because it's double the coefficient. Okay.